Okay, this next unit is our chemistry part 2 unit, which means we're going to go into more details and more information about chemistry. And we're going to start off with an essential question. Imagine how the atom has impacted our present and future world. So learning about matter and learning about the structure of an atom has impacted our past and our present. So let's take a look at an example of that. And watch a short clip on the atomic bomb explosion. Replay. Okay, let's try this. I'm going to show that again on full screen. So that's just one example of how our information about the structure of matter, atoms, have impacted our world. Okay, so our essential question for the day is imagine what the atom structure would look like and how the atom has impacted our world, present and future. So this is Learning Target 38, describe parts of an atom. So we've gone over this target before in 6th grade, so this video should be a review with a few new terms. And pretty much this target is just getting those basic terms across, the basic vocab that you need to know in order to move on in our chemistry part 2 unit. So we're going to start with what the atom is. It's the building blocks of matter. All matter is made up of atoms. And atoms are made up of three particles, protons, neutrons, and electrons. This is a picture of an atom. Notice the protons and neutrons are inside the nucleus, electrons are on the outside in electron clouds. An element, remember from 6th grade, is a pure substance. It can't be broken down into anything but what it is. All atoms of that element have the same atomic number or number of protons. So if you take a look at oxygen, if an atom has 8 protons, that's its atomic number, then we know that that element is oxygen because only oxygen atoms have 8 protons. Remember, protons do not change with an element unless you get to certain incidents, which I will get to later. Okay, so we look at the atomic number or the number of protons to define an element. The nucleus is the center of the atom. It contains the protons and the neutrons. So that's our mass of our atom. Remember, protons are the part of an atom that have a positive charge. Neutrons have a neutral charge. And electrons have a negative charge. Now also, remember, in order for an atom to be stable, the number of protons and the number of electrons must be equal because the overall charge of an atom has to be 0. So if we have more protons than electrons or more electrons than protons, then that atom is going to either have a positive or negative charge, and that atom by itself will not survive. So we So for every atom, it has to have an equal number of protons or electrons to have a neutral charge. This changes when we get into bonding to make compounds. Now, all matter has what we call a strong force, or intermolecular force, that holds the nucleus together, keeping the protons and neutrons together, and also keeping those electrons near the protons. The atomic number, remember, is the number of protons and electrons found in an element, because if you know the number of protons, then you also know the number of electrons. The atomic mass is that number on the periodic table that's below. It's usually a decimal, written as a decimal. It's below the symbol. Remember, the atomic number is above the symbol. The atomic mass is a weighted average of all the isotopes of an element. So remember, elements can have different number of neutrons, not protons, but neutrons. And if the number of neutrons changes, then that's called an isotope. So atomic mass is just a weighted average of all the isotopes of an element, the mass of an atom, which is its nucleus, protons plus neutrons. Now when you get to a mass number, that is one particular atom. That mass number will tell you the number of protons and neutrons. It will be a whole number because it doesn't include the isotopes. All right, shells. So these are energy levels outside the nucleus where electrons are found. Electrons that are closer to the nucleus have the least amount of energy because there's a stronger force between the protons and electrons. So if you look here, this first energy level, okay, that can hold a maximum of 2 electrons. These electrons are closer to the nucleus, which is a positive center because of the protons. Remember, neutrons are neutral. So the closer you are, then that means that there's a stronger attraction. These electrons that get into these outer levels, especially that last outer level, which is called the valence shell, they don't have as strong of attraction. That's why these electrons are what we use in bonding. So electrons farther away from the nucleus have more energy, they have more kinetic energy, and are easier to use for bonding to make compounds. There is a certain order to the energy level. The first energy level will hold 2 electrons, and then the rest will hold 8. So we practiced with this in 6th grade. And the last thing, the valence electrons, the electrons in the outermost shell is what determines how they will bond. For example, helium has 2 valence electrons, and you're going to get a lot of practice with this. Okay, so that is your vocab that basically describes the part of an atom for learning Target 38.